All right, check it out. We have a huge lesson right here. There's so many important ideas that we're going to talk about as we're looking at parabolas, we're looking at quadratic functions. And we know a quadratic is a polynomial that has a highest exponent of 2. It's a polynomial with a degree of 2. A quadratic, when we graph it, it looks like a parabola. We know a parabola is that U-shaped function. And so this first thing we have right here, we just want to graph this quadratic. We want to graph it. It says making a table of values to be on it. Here we are. I mean, you made a table of values in Algebra 1. You made a table of values in Algebra 2. Here we are. This is pre-calculus. Do we need to make a table of values? Well, look, you should be able to do that. You should be able to plug in numbers. You should understand that a function, when we put in values for x, we get out values for y. These are points that we can plot. If we take our calculator, we type in that function right there. I'm going to hit zoom 6. We let the calculator process that, and we can see now what it looks like. And we know the calculator gives us a table of values. We know we have that table button right there. So if we do second graph, we can see that table of values. And so we can see that we have 0 gives us 4, 1 gives us -2, 2 gives us -4, 3 gives us -2, 4 gives us 4, and so on. We can plot these points. 0, 4, 1, -2, 2, -4. There we go. So we have that right there. Now, there's so much that we can learn by looking at this right here. There's so much going on that the calculator just did. And I want to bring it all together as much as I can right here, right now. So first, parabolas are symmetric. Did you notice that? When I started plotting these points, I started noticing it's coming back up. Then I knew right here is the center of my graph. And if I'm right here at the center of the graph, I'm over 1 to the left. I'm also going to be over 1 to the right. It's symmetric. And so right here, this point, I knew I had a point 2 units from the center, from the axis of symmetry. So then I'm also going to have a point 2 units to the right. Okay? So quadratics are symmetric. This line right here is the axis of symmetry. The axis of symmetry in here is one of my biggest headaches that I noticed. Look, I'm telling you things, mistakes that I'm going to get. The axis of symmetry is not a number. The axis of symmetry, this is a line. This is a line. Axis, it is a line. And to express that line, we need to give an equation. This right here is a line that goes through this vertical line that goes through the x-axis at 2. And so that equation is x equals 2. It's an equation. Okay? It's an equation. So that's important. Okay? I get telling you, the first time someone's going to just put 2, axis of symmetry, 2. It's not 2. It's x equals 2. That's important, okay? Now, if you wanted to find that without doing all this graphing and stuff, the axis of symmetry can be found x equals -b over 2a. Look back at our function. -b, -8. b is -8, so -b over 2 times a. -b over 2a, we've got 8 over 4, which gives us 2. Our axis of symmetry, x equals negative b over 2a. X equals 2. Axis symmetry. The center, the line of symmetry. Okay, now the axis symmetry always passes through the center. That turning point right there, that point is really important. We call that point the vertex. The vertex of our parabola will either be a maximum or minimum. It's either the highest point of our function, or the lowest point of our function. Well, clearly this vertex in this function is the lowest point. So in this case, this vertex is a minimum. This vertex is a minimum. This vertex, this point, is 2, negative 4. Notice the 2 is the x value. The x value comes from the axis of symmetry. So if we needed to find the vertex without graphing, we know the x value is going to be negative b over 2a. The y value is our function evaluated at negative b over 2a. It's taking that x value and plugging it in for x. F of negative b over 2a. So that's how we can find our vertex. Okay, pretty good. Okay, bringing some more of that together. Let's think about the domain and range. The domain is the possible x values. What x values? Well, this is a polynomial, and a polynomial, all polynomials have the same domain. X values, it's moving to the left. We can see it's opening to the left, it's opening to the right, it's covering all x values. So the domain is all real numbers. We can express all real numbers one of two ways. We got a symbol. We can say everything from negative infinity to positive infinity. The range, it helps that we've talked about our vertex. We know there is a minimum value. That minimum value was negative 4. Negative 4 was the lowest y value. The range is asking for what are the y values. We know the minimum is negative 4, and then it's going up. Negative 4 is the lowest, it is the minimum y value, and then it goes up from there. So we can say all y values greater than or equal to negative 4. Now, this is a really basic mathematical way to show that. Right now, that's fine. Just trying to think about what's going on, but this is the notation that we need to use. Maybe not today, we'll talk more about this notation, but this notation saying negative 4 is included in the range, but then it goes all the way to positive infinity. So the range is starting at negative 4, going to positive infinity, all y values equaling or greater than negative 4, but we want to be able to express it like that. Maybe not today, maybe not tomorrow, but probably next week. All right. It's a good start. Let's move on. Let's carry on. Here's a lot of the same information we just said. They talk about the y-intercept. Of course, we can see what the y-intercept is too, but I think we know what a y-intercept is. I think we got that. Okay, it's asking us to put all that information together. the axis symmetry, the y-intercept. Let's do that real quick. Let's try not to use a calculator on this. Let's try to just put together some things. First, the y-intercept is always the constant value. So the y-intercept is -3. Let's use our axis of symmetry. The axis of symmetry, we know, x equals -b over 2a. That would be a -2 over 2 times 1. -2 over 2. The axis of symmetry is at -1. So there's the center of our graph. And our vertex, the vertex, we just found the axis of symmetry. The vertex, we know it's that -b over 2a, and then f of -b over 2a. -b over 2a was -1, and the y value is going to be f of -1. We're going to plug in that x value to find the output. So if we put in a -1, we've got 1 minus 2 minus 3. 1 minus 2 is a -1, minus 3 is -4. So we've got our vertex. We've got the center of our graph. We can now use the symmetry. If it's 1 unit to the right, it's going to be 1 unit to the left right there. And now we have an idea of what this graph looks like. Notice one last thing that I know I haven't said quite yet. Because our a value is positive, our leading coefficient is positive, this quadratic is opening up. Okay, we've talked about minimum and maximum values. Minimum, maximum, it all depends on the vertex. Depends on if it's opening up or opening down. We just have to think about that. We have to visualize or look at our graph to determine if it's a minimum or a maximum. If it asks for the minimum or maximum value, it's asking for that y coordinate. If it's talking about the minimum or maximum, it's referring to the vertex. But if it's asking about the minimum or maximum value, it's referring to that y value. Okay, right here, determine if this function has a maximum or minimum value. We'll look at this quadratic. It's got to open down because of our leading coefficient being negative. Because it opens down, this vertex is a maximum, so we must have a maximum value. Find the maximum or minimum value. Okay, well first it starts with finding the axis of symmetry. The axis of symmetry, x equals -b over 2a. That would be a -12 over 2 times -3. This is -12 over -6. And so the x-coordinate, we're looking at this vertex, the x-coordinate's 2. We need to know the y-coordinate. So we're going to plug that in for x. We're going to find the y value. F of 2 is -3 times 2 squared plus 12 times 2 plus 11. -12 plus 24 plus 11. 12 plus 11 gives us 23. Ooh. Okay. So what is, well, first it is a maximum value. It's 23. We're asking for the value. They want the y coordinate. Finally, staying the domain and range. The domain, this is a quadratic, so we know the domain is always all real numbers. The range, well, this is opening down. So again, we have the okay way of saying this is all y values less than or equal to 23. Okay, because 23 is the highest, so it's all these y values down here, okay, but once we get to 23, that is the highest y value. But the best way to say this answer would be all values from negative infinity to 23 inclusive. If you want more information on how to use this notation, which is interval notation, it is the first video in chapter 1, I believe. Okay. Now, if we want to solve a quadratic, we have multiple ways of solving a quadratic. We can solve a quadratic by graphing it, by looking at where it crosses the x-axis. Okay, solutions of a quadratic. These are x-intercepts. These are also called zeros. These are also called roots. When we're talking about solutions, we're talking about solving a quadratic, we're talking about where it crosses the x-intercept or the x-axis. We're talking about where the function equals 0. Okay, so the first and easiest way is to solve this by factoring. This is the quickest way if you're trying to do it by hand. Like I said, you could graph it to solve. Solving by factoring is quick. If it's factorable, if it's not factorable, we have other methods. We have the quadratic formula. You could also use completing the square. So solving by factoring. To solve this by factoring, I am going to first factor it. Okay? Looking for two numbers that multiply to get 12, add to get negative 8. Once I have factored with my function set equal to 0, I can use the zero product property. The zero product property allows me to set each factor equal to 0 and solve these simple little equations. We have x equals 6. We have x equals 2. The zero product property, really helpful, but you have to be able to factor. So, you know, very important. Very important. Okay, completing the square. Completing the square is a lot easier than it sounds. Here is some steps from the book, but let me show you my steps. I'll make it as easy as possible. So, what's different about completing the square is we actually don't want to set it equal to 0. It's weird like that. The other methods of solving a quadratic, we want it to equal 0. In this case, we're actually going to move over the constant. Okay, so let me rewrite it up here. We've got x squared minus 4x equals negative 1. Okay, first step. Now I'm going to show you these steps really slow, and I really would take time to do each step individually. We're going to group the x terms together, the terms with x together. We're going to group them together with parentheses. We're going to leave some space inside the parentheses. And we're going to tell ourselves this rhyme. We're going to take the coefficient in front of the x. We're going to cut it in half and square it next. Take the coefficient in front of the x, cut it in half, square it next. Half of 4 is 2. 2 squared is 4. We're going to paste it on the inside. I'm adding 4 to the inside. Now remember, whenever we do something to an equation, whatever we do to one side, we have to do to the other side. Because we added 4 right here, we have to add 4 over here. Took the coefficient from the x, cut it in half, squared it next, pasted it on the inside, put it on the other side. Whatever we do to one side, we have to do the other. This is now a perfect square. This factors to be x minus 2 squared. It'll always be half of that coefficient. Over here, we're left with 3. Okay, take a second, realize what we just did. Now we can solve. Okay, now we can solve for x. We take the square root of both sides, leaves us with x minus 2. Because we took the square root, we have a positive and negative square root of 3. Add 2 to the other side, we're left with x equals 2 plus and minus the square root of 3. Not as bad as it looks. Okay. Finally, quadratic formula. You probably remember quadratic formula. I'm not saying you don't. All right. Quadratic formula. There's a lot of good songs. You should know quadratic formula. I'm not going to give you quadratic formula. Know it. Learn a song. Memorize it however you want to. You have to know quadratic formula. This is our last way of solving a quadratic. And we do want it to be equal to 0 here. Once it's set equal to 0, we can plug in our a, b, and c. It's negative b, so a negative 4 plus and minus the square root of b squared minus 4 times a times c all over 2a. So this is 4 plus and minus the square root of 16 minus 60 all over 2. This is 4 plus and minus the square root of negative 44 all over 2. We want to simplify that square root of negative 44. First, we know the square root of a negative is I, so this is I times the square root of 44. 44 does break down to be 2 times 11, so this is 2I square root of 11. So we have 2 plus and minus 2I root 11 all over 2. Notice this is a complex number, so we want to give it a real part and an imaginary part. When we divide the first, we have 1 plus and minus. The 2's cancel out right here, leaving us with I root 11. Okay, notice what happened right there. When I just simplified, I did it kind of quick, that was 2 over 2 plus and minus 2I root 11 over 2. Those simplified to be this right here. Okay, that was a lot of stuff with quadratics. Practice it. Feel confident.